So in today's lesson, really the goal is to be able to be given a graph and take out key pieces of information and relate that to a word problem. So we're comparing sinusoidal functions. And a sinusoidal function can be used as models to solve problems that involve circular or oscillating motion. There's that oscillating word I used in the last lesson. Oscillating, if you think of like your tire or your washing machine. That's not washing machine. Yeah, like your dryer, right? Like something that like goes in a circular motion. That's what it means when it like oscillating. And at a constant speed, okay? That's actually very important that it has to be at a constant speed. One cycle of motion corresponds to one period, and we know that. That's from previous lessons. The amplitude of the sinusoidal function depends on the situation being modeled. So that is what we're going to be covering a lot of today. We're trying to take pieces of information, words like period, amplitude, and be able to actually relate them to a word problem and give it some context, okay? So in example 1, at an amusement park, Mr. Phillips had different math students ride 2 Ferris wheels. Ben rode Ferris wheel A and Maya rode Ferris wheel B. Mr. Phillips collected data and produced 2 graphs. All right, so in these graphs, we have Ferris wheel A and Ferris wheel B. So just to understand what these graphs are measuring, all right, we have height and we have time. So if you actually think about riding a Ferris wheel, right? Like, you have your Ferris wheel. I'm not a great artist, but I'll try my best. So we have our Ferris wheel like this, okay? All right, so let's say, you get on the Ferris wheel right here, right? At 0 seconds, you get on it. And then your height is whatever this height is. We don't know. But what we do know is that as this Ferris wheel starts to go around and start to spin this way, let's take a snapshot right here, right there. Well, time has gone forward, right? So like, let's say we're at, 3 seconds, give it some numbers so we're not dealing with nothing but variables. See, at 0 seconds, you were at the start. But 3 seconds later, we can visually see we are higher, right? Like we are at, let's say we are at this height right here, right? So you've gone here. And then, and let's say another 3 seconds passes and you've gone higher, like, you're at the top of the Ferris wheel now. So now another 3 seconds goes by, and you're now up here. So let's keep connecting our dots, right? So another 3 seconds went by. So now it's 6 seconds total. And then you reach the maximum and then you start to go down, right? You start to go down. Let's say another 3 seconds pass and you get back to halfway. So we're back to this spot right here, right? 3 seconds later. So your graph looks like this now. And then another 3 seconds goes by and you get back to the start and you ask the amusement guy, can I keep going or not, right? So you get back to the start right here like this. Like that, right? So you went up, you went down, you came back to the minimum, right? Came back to the start. And then if you were to go again, right? If you were to ride this Ferris wheel one more time, well, you would start to go up again like this. You would hit the maximum of your Ferris wheel, and then you would start to come down. You'd reach the halfway point again, right? Like this dotted line right here. And then you would go down to the start, and then you would ride it again, right? And you can see how it's just a repeating pattern of up, down, like this. But the goal of me drawing out my very, very poor drawing is really for you to grasp the concept of like, okay, well, what this sine wave is here, because this is a symmetrical and smooth curve, what it is actually graphing is the height that you are traveling across a certain time. And because, as you spin around the Ferris wheel, as you go up and down, it is a pattern of going up and down. So you create a sinusoidal wave. So let's look at what this period represents. Like in the first problem here, what is the period of each graph? So just outside of the word problem, before we talk about what it represents, how do we find period? Well, you look for two parts on a graph that are very easily identifiable. So in the previous lesson, it wasn't the peaks that were most easy, it was actually halfway down. But in this one, you can see that the peak right here falls nicely on a dotted line, right? Like I can look and I can say, oh, okay, so there's the peak, that's at 10 seconds. And then I have my other peak right here, and that's at a value of 50 seconds. So how far apart are these two right here? Well, that is 50 minus 10, so that gives us a value of 40 seconds. They are 40 seconds apart from each other. So Ferris wheel A, well, its period is then 40 seconds. Well, let's look at Ferris wheel B. So Ferris wheel B. I'm going to put an underline on this, just make the lessons look nice. Okay, so same thing, let's find our period. So find points that are easily identifiable, troughs or peaks. So once again, I can see that the peak here falls nicely on the graph. So I'm going to look down. I'm like, okay, cool. That's at a value of 10 seconds. And when you're looking at period, you're looking at the x-axis, right? Because you're asking that question, how long does it take? So how long is a time value? And you reach the next peak at 50 seconds. Oh, perfect. So once again, it is 50 minus 10, giving you 40 seconds. So actually, both Ferris wheels have the same period. Okay, well, let's go back up to my analogy, right? When you get back to the same part, right? These are the same part, but remember, they're not the same because you're going down here and you're going up here. But if you find the same minimum, right, the distance between your minimum or maximum, that's your period. And in the context of this Ferris wheel, these minimums that I've drawn here, that's when you started the Ferris wheel, right? Like that's when you hopped on. Or vice versa, if you were to look at the maximum, that's when you reached the top of the Ferris wheel. So if you were to go around twice on this Ferris wheel, you'd be at your maximum. So what does the period represent in each graph? Well, the period, and these are classic, by the way. This is, Ferris wheel is like your class example of an oscillating feature, but like the concept is the same for any type of circular motion. What the period represents is one cycle, the time to complete one cycle, or in this case, the time it takes for one ride of the Ferris wheel, right? How long it takes you to go around from getting on to getting off. And that's one cycle. Okay, part B. What is the equation of the axis for each graph? What does the equation of the axis represent for each graph? So remember, our equation for the axis is you taking the max, so your axis, and again, we can give that the value of d, right? So, I'm always calling it axis. So let me just say d this time. And that's taking your maximum and subtracting your minimum and dividing that by 2. Oh, she's the other way around. adding these. I always mess up, but it's okay. So adding them. So let's look at the graph here and let's say, okay, well, what is my maximum for each Ferris wheel? So if I look at, I'm just gonna denote Ferris wheel A as A, just speed this up a bit. So A, well, if I look at my maximum up here, well, I have a max height of 13, is that 13? That's 11, 12, yeah, 13 meters, right? And so in part A, your max is 13 meters. I mean, that's the max, that's like the highest the Ferris wheel will go to. And then you're hopping on 1 meter above the ground. So it might be like a platform that you're standing on when you get on the Ferris wheel. So the minimum for A is 1 meter. So then if we take these values, right, so our D is then 13 plus 1, divide that by 2. So that's 14 over 2, or 7 meters, okay? So I'll talk about what this represents in a second. Let's just do the same thing for B. So let's get our value for B. So doing, once again, let's determine what our maximum is. I'll do it in a different color so we can see that they're different. So maximum. So if I look at my graph here, okay, well, my maximum is at 7 and my minimum is at 1. So my max is 7 meters. My min is 1 meter. So apply the same formula, your axis symmetry, or D. So just call this axis again. Your equation of the axis is D, which is max plus min. Divide that by 2. So that's 7 plus 1 divided by 2, giving you 8 over 2, or 4 meters. Okay, so let's go back up to my very poor drawn picture at the very, very top here. Let me get rid of all these circles, because that just makes it look messy and harder to see. So, okay, so the axis of symmetry, right? You're finding the point where it cuts the graph in half, right? Well, let's look. That cutting graph in half, that's this dotted line right here, right? And let's go over and look at our graph of where that dotted line came from. That is the center of your Ferris wheel, right? That is how high the center of the Ferris wheel is off of the ground. That's what the axis represents. So in this context right here, we have two different axes, right? We have 7 meters and we have 4 meters. So what does it represent in this problem here? Well, Ferris wheel A, so right, FW for short. Ferris wheel A is 7 meters off the ground. Ferris wheel, and therefore, Ferris wheel B is 4 meters off the ground. Right? It's how high it is off the ground. And we got that just from like the picture of what you're doing, what we're looking at over here. So what is the amplitude for each graph? Well, and I say ground, by the way. Let me actually check, because I just thought about this as I was reading this problem. Ground. This is 7 meters off from your lowest point. Lowest point. Whatever you defined the 0 point to be, okay? So if you defined the 0 point to be the ground or the minimum, it's just the lowest point. So it's 4 meters off the lowest point, the 7 meters off the lowest point. So what is the amplitude for each graph? What does the amplitude represent in the Ferris wheel? Well, remember, the amplitude, if we have a graph, right? So this is your general sine graph. Let me just draw it with a dotted line here. Let me put this dot actually on the, okay, and make it more symmetrical. There we go. All right, so the amplitude is this distance right here, right? There is your A. This distance right here, that's your A. Well, if we think about our Ferris wheel problem, we have some Ferris wheel where the axis represents the center of your Ferris wheel. So actually, let me not connect that. It represents the center of your Ferris wheel. And you have this max that corresponds right here. And you have this min right here. And let me draw it bigger, actually. My very, very poor circle. Sorry, like I said, I'm not an artist. There is your min. one more time, just so I can relook at. There's your Ferris wheel. I'm sorry. And you can see your amplitude is this distance right here and right here. This is your A. This is your A. So if you think of a Ferris wheel as a circle, I know it doesn't look like a circle, but it is a circle. Well, going back to your geometry, what is the because these are equal, right? These are equal distance from top to bottom. What is that value in context to a circle? Well, that's equivalent to like your radius, right? Your radius. So if we were to calculate our amplitude for these problems, we're going to use our formula, A equals max minus min over 2. So if we apply that formula to Ferris wheel A, what we are going to be finding is the radius of the Ferris wheel. So how large, and it's like, like the distance from the center to the top, or vice versa, the center to the bottom. So A is max minus min, so we can just look up right up here and see what our values are. So 13 meters minus 1 meter, divide that by 2. So that's A is 12 meters divided by 2, or 6 meters. So that means that Ferris wheel has a radius of 6 meters. And if you do it for B, well, our A value is max, so in this case it's 7 meters minus 1 meter. Divide that by 2. That's 6 meters over 2, or 3 meters. So that's a radius of 3 meters. So what does the amplitude represent on the Ferris wheel? The amplitude is the radius of the Ferris wheel. And this will always change, like the Ferris wheel. Like it does, I can say, like, I can give you a bicycle problem, right? Well, if I ask you, like, your tires on your bicycle are spinning, well, the amplitude, the value, look at the graph and you see the amplitude, that's how large the radius of your bike tires. So therefore the amplitude is the radius of the Ferris wheel. Ferris wheel A, radius of 6 meters. Ferris wheel B, radius of 3 meters. Oh, I put a blank page in here. I'm not sure why. So, which Ferris wheel is larger? Justify your decision. Well, we found the radiuses. So essentially we're saying, okay, well, I have a circle that has a radius of 7 meters. That's your Ferris wheel A. And then I have a circle. I'll do it in blue because I've been doing B in blue. I have a circle with a radius of 3 meters. So visually, you can even just look at it. Which Ferris wheel is larger? Well, Ferris wheel A is larger. It has a greater amplitude. Okay, just to see this comparison, amplitude, which is your radius, i.e. radius. Okay, determine the speed of each Ferris wheel. So remember speed, all right? Speed is distance over time. And if you struggle remembering that, like, just think about your everyday life and when speed comes into context. Like you're driving to school and you have a speed limit, right? And it's how fast your car is allowed to travel. Well, when you look at your speedometer on your car, it has units of kilometers per hour, right? So kilometers is a distance value and hours is a time value. So that's your speed, right? But in this problem right here, it's slightly different because we're not traveling in a straight line when we're doing sinusoidal functions, right? So it's not like you can say, well, take a tape measure and measure your distance here and say, well, how long did it take me to get that? No, in a Ferris wheel or just any circular motion, right? You are starting at the bottom or wherever, and you are traveling in a circle, right? So you're going in a circle all the way around. So if you were to say, well, how long does it take you to walk this path along this distance? Well, what you need is you need the circumference. You need the circumference. And circumference of a circle is 2 pi r, okay? So r is the radius of the circle. Because circumference is like the perimeter. It's how long you are walking. So if you have a circle and you know your radius, which we do now in these problems, you can calculate how long of a Ferris wheel it is. Like, what is the distance you'd have to walk around it? So in these problems, when you are calculating speed, okay, speed in these problems is 2 pi r. Actually, I'll just write it like this. Circumference, the circumference divided by time. So, and the time is saying like, well, how long does it take you to do one revolution? So divided by your period. So the speed, so S, is 2 pi r divided by p, whatever p is, right? So if we compare our different Ferris wheels, well, for Ferris wheel A, our circumference, our C, so this is C equals, our C is 2 pi r, and r is 7 meters from before, right? We have a 7 meter wide Ferris wheel. So our circumference here, if we 2 pi times 7, right? Pi is just a number, like it's a button on your calculator. So it's 2, and it's all roughly 3.14. So 2 times, I have to use the shift button on my calculator, times 7. I get 43.98 meters. It's a distance, right? And if I do that same thing for B, B's radius is 3 meters. Well, B's circumference is 2 pi times 3. So that's 2 times shift pi times 3. Oh. So that's 18.85 meters. Okay, so now we need our speeds. So the speed of A is n. Okay, so we need our S is equal to that 43 C over P, circumference over P, which we have our circumference being 43.98, and our period was how long it took us to do one revolution. So we found that at the very beginning, right? Going way back up here, the period of each of these was 40 seconds. So if we go all the way back down here, the period is 40 seconds. And remember, this is units of meters. So we are going 43.98 divided by 40. You're going to get a speed of 1.1 meters per second. Well, the speed of B, same thing, is at circumference over period. So our circumference was 18.85. Divide that by the period, so 40 seconds also. We get and remember this is units of meters. So 18.85, divide that by 40. We get a speed of 0.47 meters per second. So clearly A is traveling much faster. It is a bigger Ferris wheel, and it takes the same amount of time for it to get back to the beginning. So yes, it's got to travel faster. Actually, I don't even know why I boxed it. Actually, the speeds are here. Got to box both. It wasn't like I was comparing. Okay, last example. Sketch a height versus time graph of the sinusoidal function that models the following situation. Assume the first point plotted on the graph is at the lowest possible height. Yeah, see, this is what I was talking about. The lowest possible height when I was referring to the whole axis of symmetry. You have to define where your low point is. A water wheel with a radius of 4 meters, whose center is at water level and rotates once every 40 seconds. So reading these problems, let's learn how to dissect a certain piece of information. Well, the radius of 4 meters, that means your amplitude equals 4 meters, whose center is at water level, okay, and rotates once every 40 seconds. All right, so once every 40 seconds, rotates once, that means one cycle. And every 40 seconds, what that means is the period is 40 seconds. So if the graph is saying sketch the height versus time, assume the first point of the graph is at the lowest possible height. All right, well, doesn't really tell us any maximum or minimum here. All we need to know then is that your distance from your max and your min, if we think about the radius being 4 meters, that means if we have 4 meters as a radius, 4 meters on going there, and this also is 4 meters, right? If like this was spinning, your diameter is essentially your diameter, which is your distance between max and min, is 8 meters. So these are your amplitudes, right? So it's saying put our minimum at the starting point. So let's plot our minimum like that. And then it's saying our maximum is, and it's saying that this needs to be level here. So it's saying that we're starting at our lowest point. So we need a distance of 8 meters. So -4 to 4, this distance right here, this distance is 8 meters. Okay, so we also need to then graph our period. So if we say whose center line is at water level, we're assuming this to be water level. Because you're going to have this water wheel that is going to go, it's going to go -4. It's going to go below water level. It's going to go -4 down, and then it's going to go up 4 meters, right? Like, if you think of those old mills back in the day. And it takes 40 seconds from it to go from its lowest point right here back to its lowest point. And we need 40 seconds across. So let's just call each one of these ticks, I don't know, 5 maybe. So 5 seconds. So 5, call this 10, 15, 20. I'm going to run out of room, so I'll skip a few. So 10, 20, 30, and 40. So we need to complete one cycle in 40 seconds. So if it has to start at its bottom, that means we need to start right here. And at 40 seconds, we need to end back here, okay? All right, well, where is your halfway point between these? Because remember, we got to hit our maximum. Our graph goes like this, right? It's going to go like this. Right, it's a sinusoidal graph. So generally speaking, we're going to be starting at our minimum, going to our minimum. So the halfway point right here, the halfway point, that's going to be where your maximum needs to be. So halfway between 0 and 40 is 20 seconds. So that's right here, right? So that means around the 20-second mark, so at the 20-second mark, you need to be at your maximum right there. And now just connect the dots and just try and draw a smooth curve. So you're going from your minimum up, you are hitting your maximum, and then you're going down and you're hitting your minimum. And if you were to keep this graph going, I'm going to draw in a different color, right? So you would have the same pattern going. You'd have like this oscillating Ferris wheel, or sorry, Ferris wheel, water wheel, right? Doesn't matter the context, but it's all the same. So here you can see you have a 4-meter radius and it takes you 40 seconds to travel. Okay, so that's it for now. I'll see you at the next lesson.